Hello, bright minds. Have you ever wondered why every appliance in your house seems to get the same zap of electricity no matter where it's plugged in? Well, that's all thanks to domestic electric circuits working quietly behind the scenes. Here's a fun thought. Why did the electrician become a great musician? Because he knew how to conduct himself. Now, speaking of conducting, a domestic electrical circuit supplies electric power to various appliances all around your home, and it does this mostly by arranging everything in a parallel configuration. This clever setup makes sure each appliance gets a consistent voltage, so your fan spins happily even if the toaster is busy making breakfast. In India, electric power is supplied at a voltage of 220 volts and a frequency of 50 Hz using live and neutral wires. But electricity can be a bit wild, so devices like fuses or miniature circuit breakers, MCBs for short, are installed for safety, preventing damage or fires by cutting off power if something goes wrong. Because appliances are all connected in parallel, every device receives the full 22 volts it needs and works independently. This means if you switch off your TV, your refrigerator keeps running without a hiccup. Important components like electric meters track how much energy you use, distribution boards coordinate power to each circuit, and safety equipment like fuses and earthing systems help keep everything running safe and smooth. So next time you flick a switch, remember the invisible teamwork making your life comfy and bright. Hey there, curious minds. Have you ever noticed those colorful wires inside an electric plug, red, black, and green, and wondered why they're not all the same? Well, they're not just for show. Each one plays a superhero role in keeping your home powered and safe. Let's start with the live wire, usually red. It's the energetic one, carrying current straight from the mains to your appliances. Then comes the neutral wire, mostly black, quietly completing the circuit by sending current back to the source. Together, these two make sure your fan spins, your lights glow, and your gadgets stay alive. But what happens if something goes wrong? Say, the insulation fails or a wire comes loose. That's where our third hero enters, the earth wire, dressed in green. It's like the bodyguard of your appliances, channeling stray currents safely into the ground to prevent shocks or fires. In India, the potential difference between the live and neutral wires is about 220 volts, the perfect amount to power your domestic devices efficiently. And thanks to earthing, there's always a low resistance escape route for any fault current, protecting both you and your electronics from nasty surprises. So next time you plug in your charger or switch on the iron, remember, the live wire brings the power, the neutral wire returns it, and the earth wire keeps you safe. It's the perfect trio working together to keep electricity flowing smoothly and safely through your home. Alright, science explorers, imagine this, your TV, washing machine, and heater are all running at once, and suddenly, boom. Too much current tries to rush through the circuit. What stops it from turning your home into a fireworks show? The unsung heroes, fuses and MCBs. Let's start with the fuse. It's like the circuit's personal bodyguard. When current flows beyond the safe limit, the fuse says, "Nope, that's too much," and melts instantly, breaking the circuit. This tiny meltdown prevents overheating, fire, and damage. Typical household fuses are rated at 5 amperes or 15 amperes, just enough to protect your appliances without interrupting your movie night. Now, here's the math behind it. Whenever the current I becomes greater than the rated current I rated, the fuse blows. Simple rule, I greater than I rated means fuse sacrificed. But what if you don't like replacing fuses every time? That's where the MCB, or miniature circuit breaker, steps in, the smart, reusable version of a fuse. It senses overloads or short circuits and automatically trips the circuit off, almost like saying, "Hold on, something's wrong, let's pause." You can simply reset it with a switch, quick, safe, and efficient. And guess what? Both fuses and MCBs are always connected in series with the live wire. Why? So that if a fault occurs, they completely stop the current flow, ensuring total safety. So, next time your power trips suddenly, don't panic, that's your circuit giving you a high five for being safe. Hey learners, imagine this, you've got a string of old decorative lights. One bulb fuses and boom, the entire chain goes dark. Frustrating, right? Well, that's exactly why series circuits aren't invited to your home's wiring party. In our homes, we use parallel circuits instead, and for good reason. In a parallel setup, every appliance, whether it's your fan, TV, or laptop, gets the same 220 volts of power. That means each one performs perfectly without fighting for voltage like kids sharing one toy. Here's the cool part, in a parallel circuit, the total current drawn is simply the sum of currents through each branch. Mathematically, that's I equals I1 plus I2 plus I3 and so on. So, while each device enjoys its own steady voltage, the current divides smartly between them. And here's the big advantage, if one device stops working or you switch it off, the rest keep running happily. That's independence in action. Your refrigerator doesn't throw a tantrum just because your TV took a nap. Series connections, on the other hand, are like a single queue in a crowded canteen. If one person stops, everyone waits. Appliances in series would get less voltage and work poorly, making them totally impractical for household use. So next time you turn on multiple gadgets at once, remember, it's the magic of parallel circuits keeping everything bright, cool, and running smoothly. Hey everyone! Have you ever wondered what exactly that electricity bill at the end of the month is really charging you for? No, it's not for how many times you opened the fridge. It's actually based on how much electrical energy your appliances have used. Let's see how it all adds up. Every electrical device, whether it's your bulb, fan, or washing machine, consumes energy depending on its power rating and how long it runs. The formula is simple, E equals P times T, where E is energy, P is power in watts, and T is time in hours. Now, in electricity bills, we don't measure energy in joules, that number would be way too huge. Instead, we use the kilowatt hour or kWh. 1 kilowatt hour equals 1000 watts multiplied by 3600 seconds, which means 1 kilowatt hour equals 3.6 times 10 to the power 6 joules, quite a lot of energy for your morning coffee machine. When the electricity board calculates your monthly bill, it adds up the energy used by all your appliances. The total equals the summation of Pi multiplied by Ti. That's the sum of each appliance's power multiplied by the time it was running. And that's where power ratings come in handy. They help you estimate your energy usage so you can balance your load, avoid high bills, and maybe save some cash for pizza instead. So next time you switch on your geyser or air conditioner, just remember that ticking meter outside your house is keeping count of every watt-hour you use. Hey there, future engineers. Ever plugged in your iron or fridge and felt a tiny tingle? That's your body saying, "Yikes, electricity is escaping." But don't worry, science has got your back. Let's talk about how earthing keeps you safe from electric shocks. Earthing is like giving electricity a safe escape route. It connects the metal parts of your appliances, the ones that shouldn't normally carry current, straight to the ground through a low resistance wire. So, if any current leaks due to a fault, it flows harmlessly into the earth instead of through you. Now, here's the simple physics behind it. the current through the earth wire is given by I sub E equals V divided by R sub E, where R sub E is the earthing resistance. The smaller this resistance, the faster the leakage current runs to the ground, like taking the express lane to safety. But modern homes go a step further with MCBs, or earth leakage circuit breakers. These smart guardians can sense even a small leakage current and instantly cut off the power supply before you can even blink. No sparks, no shocks, just safety. Proper earthing is especially vital for high-power appliances like refrigerators, air conditioners, and electric heaters where current levels are higher. Without proper earthing, even a minor insulation failure could be dangerous. So, next time you see that green wire in your plug, remember, it's not just a color code. It's your personal safety shield, silently protecting you every single day. Alright, let's play detective, electrical detective. Suppose you've got 3 appliances, a 500-watt lamp, a 1000-watt heater, and a 1500-watt iron, all happily plugged into a 220-volt supply. The question is, what fuse rating should we choose to keep everything safe without the fuse blowing up too soon? Now here's the smart part. We never choose a fuse exactly equal to the working current. Why? Because small fluctuations in current could make it blow unnecessarily, even when everything's fine. So, we go slightly above, P equals V multiplied by I, or rearranged, I equals P divided by V, which means the current drawn is equal to the power consumed divided by the supply voltage. Now, let's calculate the total current drawn. First, we add up the power ratings of all the appliances. 500 watts plus 1000 watts plus 1500 watts equals 3000 watts. Next, divide that total power by the voltage. 3000 watts divided by 220 volts gives approximately 13.64 amperes. That gives a little breathing room for normal variations while still protecting the circuit. Finally, let's check our logic. A 15A fuse is perfect for this setup. Choosing a 10A fuse would cause constant tripping and frustration. Imagine your appliances turning off mid-use. So, 15A it is, safe, reliable, and efficient. So, the next time you pick a fuse, remember, it's not just a random number, it's about finding that sweet spot between protection and performance. Alright, physics champs, time for a quick recap. Let's tie everything together with the key formulas and takeaways from what we've learned about household electricity and safety. First up, the energy formula, E equals P times T, that's energy equals power multiplied by time. Simple but super useful, it tells you exactly how much electricity an appliance consumes. Next, the current formula, I equals P divided by V, where current equals power divided by voltage. This one helps you pick the right fuse or MCB rating. Remember our 15 amp fuse example? Yep, this is where it comes from. And of course, the classic Ohm's law, V equals I times R, the foundation of all circuit analysis. Voltage equals current multiplied by resistance. Now, when it comes to electricity bills, keep this conversion in mind. 1 kilowatt-hour equals 3.6 times 10 to the power 6 joules. That's the energy you pay for, whether it's lighting your room, cooling your air, or charging your phone. Finally, never forget the safety side of science, earthing. It's what prevents electric shocks by giving fault currents a safe path straight to the ground, keeping you, your gadgets, and your home protected. So there you go, the perfect balance of formulas and safety. Remember, electricity is powerful, but with the right knowledge, you can handle it smartly and safely.